Hello, ladies and gentlemen. This is your review sheet for your chapter test, which is next week. Hope you enjoy the video and get it rolling right away. When you solve this, x to the 6th equals 729. Remember, this is an even root. So therefore, you need to know you need a positive and negative here. So 729, the 6th root of that. Let's go ahead and punch that out for you. Okay. So you would hit 6, math, 5, 729, and hit enter. It goes in evenly 3 times. This would be positive, negative 3. Okay, going to number 2. Close this up. Okay. It says, what is the simplified expression of the 4th root of 162, x to the 8, blah, 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 blah. I want to write this into basically nice things that I can take the 4th root of, like 81 times 2. I can take the 4th root of 81. X to the 8th is a nice one. It's divisible by 4. Y to the 12th. 12 is divisible by 4. 10 is not. So I'm going to write this as z to the 8th and z squared. So when I pull out what I can take this guy out. That would be 3. I don't know why I'm writing it like a 2. The 4th root of 81 is 3. So he is gone. 4 goes into that twice. That's x squared. This is y to the 3rd. This would be z squared, because 4 goes into that twice. And I'm left with 2z squared. There you go. So there's your first 2 problems completed. Let's go to the next 2. B of c of x. So what I'm going to do is rewrite b. So this is 2 blank squared plus 4 blank minus 5. I'm going to go ahead and put in my c of x. My c of x will go here, x cubed minus 3, x cubed minus 3. And now we're off to the races. So this will be x cubed minus 3 times x cubed minus 3. I need to FOIL that and then distribute the 2 in. This will be 4x cubed minus 12 minus 5. All right, so 2 times x cubed minus 3x cubed. I'm sorry, this is x is 6. Minus 3x cubed plus 9. This is plus 4x cubed minus 17. Remember, this is all being multiplied by 2. All right, so this is 2x to the 6th. This is negative 6x, which would be negative 12x cubed plus 18 plus 4x cubed minus 17. So what is b of c of x? It looks like 2x to the 6th. Negative 8x cubed and plus 1. All right, going down to what is the inverse of this? This is y equals 5 over 2x plus 4. So this is x equals 5 over 2y plus 4. So I'll have x minus 4 equals 5 over 2y multiplied by 2. Too much of a follow through there. So I have 2x minus 8 equals 5y. And then I'm going to divide everything by 5. So this is 2 bits x minus 8 bits equals 1. And there's my inverse. Okay, 5 and 6. Basically 5 and 6 is going to be on the next page. Start out by dividing by 6, so this is the cube root of x plus 13 equals 4. I'm going to cube both sides, so x plus 13 equals 64, and then that would be 51. Okay, and that's where I'll stop for a sec. Okay, so part 6, I'm going to simplify each expression. I'm going to break down 48. Well, remember, 2 to the 4th is 16, 3 to the 4th is 81, 4 to the 4th is huge, I get to 56. So that's clearly over 48. So let's start with this. 16 times 3 is 48. The 4th root of 16 is 2. So this is 2 times the 4th root of 3. Right? Over here, this is 81 times 2x. And then I'm going to do 16 times 2x. That's going to be 32x. The 4th root of 81 is 3. 3 is on my mind. Minus 2 4th root of 16 is 2. And I have 4th root of 2x. I can actually subtract this. This is 1 4th root of 2x. All right? Over here, break it apart. 3y squared. None of those have cube roots. You cannot take the cube root of 4x. Now the smallest number you can take the cube root of is 8. So I need to multiply 4 times 2 so I can get that cube root out of the denominator. I can take the cube root of x cubed, so I need to multiply by 2x squared in order to get an x cubed on the bottom. So whatever I do to the bottom, I need to do to the top. So up top, I'm going to have the cube root of 6x squared y z squared all over the cube root of 8x cubed. So to finish this guy, again, nothing in the numerator can be broken down. There are no cube roots there. And this is all over 2x. All right, number 7. We're going to prove that one is the inverse of the other. I'm going to do this guy, which would be y equals a half x plus 7 squared plus 3. So I'm going to switch my x and y. So I'm going to subtract 3. Half y plus 7 squared. And now I'm going to square root. So I have plus minus the square root of x minus 3 equals a half y plus 7. And I'm now going to subtract my 7 over. And I'm going to multiply everything by 2. So this is positive negative 2 times the square root of x minus 3 minus 14. And are they inverses to one another? No. Okay? Because in the first one they didn't give us a quantifier. For this to be yes, okay, the plus minus is why it's no, by the way. This is only a positive. And we need it to be positive and negative. So if you were to graph this, it would kind of look like one of these deals. There's the regular one. And then you would have the graph of the second guy that would look like, you know, only that half of the problem. And that's a no-no. It's got to match completely. So it had to have plus or minus. So that's the end of the front for you guys. Let's go over to the back. In 8. Okay, we got h of x, which is 3x to the 4th, minus jx, which is 5x minus 2. So 3x to the 4th minus 5x plus 2. All right. Kx, 4th root of x minus 5, and jx, 5x minus 2. That is in those terms, cannot be broken down. And then in C, h I'll rewrite, but I'll leave a blank where the x is, and I'm putting in k of x, which would be the 4th root of x minus 5. So, 4th roots cancel out, so this is 3 times x minus 5, which is 3x minus 6. All right, with that being said, okay, now they want us to do the domain in the integral notation for a, b, and c. So this is all real numbers, because there is no division or square roots. Here we have a denominator, so we can't have that equal to 0. That cannot equal, looks like 2/5. So everything but 2/5 will work. 2/5 positive. Okay. In C, looks like everything works again here. There's no radical or denominator. So there we go. Moving right along. Number 9, we're checking for extraneous solutions after we solve this. Let's just start by solving it. Okay, so I'm going to square both sides. So this will be 4x. This will be x squared minus 16x plus 64. Set it equal to 0. I'm going to get x squared minus 20x plus 64. And then two numbers that multiply to be 64 and add up to 20. Minus plus is minus minus. So looking at 4 and 16. So x minus 4 equals 0. X minus 16 equals 0. X is 16. X is 4. So let's give this a shot here for the check. 4 times 4. 4 minus 8. Well, 16 squared root of that is not going to be negative 4, so this is a no-no. He's extraneous. Let's try 16. Got 4 times 16, and we got 16 minus 8. And this seems to be a good go. Square root of 64 is 8. So he's good. Right, so only one answer worked in 9. And finally, the elephant problem. So the elephant is modeled by this, where T is in time in years, H is height in centimeters. So we want to know when an elephant should have ears the size of, I don't know, what? Whose shoulder height is 200 centimeters. So shoulder height, 200 centimeters, equals 62.5 cube root of T plus 75. So we're going to subtract 75.8 first. All right, 124.2, 62.5, divide by 62.5, and that's what the cube root of T will be. I'm going to need my calculator to do that. Okay. So we have 124 divided by 62.5, it's 1.98. So 1.9872. Raise that to the third. T is equal to 7.847380943. Okay, so how many years? The nearest year, 8 years old. If that equation is correct for that outcome. That's your review sheet, guys. Hope I covered everything for you. Any questions, email me. Again, hopefully you can hear my explanations and everything's good. Enjoy the warm weather. If it's not warm yet, it will be warm soon. So take care, guys. Talk to you soon. Ciao.